In this segment, we are going to solve word problems related to quadratic equations, and more specifically, the quadratic equation word problems related to number systems. So let us take a look at the first question. Divide 16 into two parts. So we have to take 16 and we have to divide it in two parts. So let one part be x, and therefore the other part is going to be 16 minus x. So I'll say that let one part be x, and hence the remaining part, or hence the second part, is going to be 16 minus x, such that twice the square of the larger part. So we have to now decide which one of these is larger. We can assume either of them to be the larger part. So let's assume that x is larger. So twice the square of the larger part, that is 2 times the square of the larger part, exceeds, so 2x square exceeds the square of the smaller part. So square of the smaller part is going to be 16 minus x the whole square by 164. So again, what we did was we took the two parts as x and 16 minus x. We assumed that x is the larger part. Of course, you could also assume that 16 minus x is the larger part. But here I assumed x is larger, which means 16 minus x is smaller. And twice the square of the larger part, that is 2 times x square, exceeds, that it is greater than the square of the smaller part. Square of the smaller part is 16 minus x the whole square, and the amount by which it is greater than is 164. And therefore this becomes 2x square minus of 16 minus x the whole square is equal to 164, and therefore 2x square minus a minus b the whole square can be written as a square minus 2 times a times b plus b square. Okay, this equals 164. So 2x square minus 256 plus 32x minus x square is equal to 164, right? And now we can solve this quadratic equation. We can say let's combine the like terms. So we get 2x square minus x square is x square plus 32x minus 256 minus 164 is equal to 0, or x square plus 32x minus 420 is equal to 0. So now we have to find two numbers whose product is minus 420 and the sum is 32. I notice that if I take 42 tens are, then I immediately have 32 as the sum. So the numbers would be plus 42 and minus 10. So x square plus 42x minus 10x minus 420 is equal to 0, which means x plus 42 multiplied by x minus 10 is equal to 0. This means x is either minus 42 or x is positive 10. Now we will not take negative numbers, right? So we will only consider the positive parts, and therefore the two parts are x, that's 10, and 16 minus x, that is 6. Let us check if our answer is right. Divide 16 into two parts. So these two are the parts of 16. Twice the square of the larger part. So let's quickly have a check box. This is checkbox. So twice the square of the larger part, that is 2 times 10 square, exceeds the square of the smaller part. So let's check how much this is. This is 10 square is 100, 2 into 100 is 200. So 200 minus 36. Now 200 minus 36 is 164, and that matches the question, and hence our numbers are right. So pausing for a few seconds before moving on to the next one. Moving on to the next question. The sum of two numbers is 15 and the sum of their reciprocals is 3 by 10. Find the numbers. So the sum of two numbers is 15. This is again similar to splitting 15 into two parts. So I would say let the two parts be x and 15 minus x. Now it is given that the sum of their reciprocals, so sum means addition, of their reciprocal. So reciprocal of x is going to be 1 by x, and reciprocal of 15 minus x is 1 by 15 minus x. The sum of these reciprocals is 3 upon 10. So now I can definitely go ahead and find the LCM, but before that I just want to repeat this. The two numbers are x and 15 minus x because we are splitting 15 into two parts. The sum of their reciprocal. So reciprocal of x is 1 by x and reciprocal of 15 minus x is 1 by 15 minus x. Their sum is given as 3 by 10. So now we can find the LCM. So the LCM of this is going to be x into 15 minus x. The numerator is going to be 15 minus x plus x, right? This term gets multiplied by 15 minus x. This term gets multiplied by x is equal to 3 by 10. Now minus x and plus x cancels, and therefore this becomes 15 upon x into 15 minus x is equal to 3 by 10. Now 10 goes to multiplication, so you get 150 is equal to 3x times 15 minus x. 3 goes down to division, so 50 is equal to x into 15 minus x, right? And now again we can open up the brackets and solve the quadratic equation. So we have 50 is equal to 15x minus x square, or I can group all terms as x square minus 15x plus 50 is equal to 0. Now we need to find two numbers whose product is 50 and sum is negative 50. So product is positive and sum is negative, means that both the numbers are going to be negative. So 50 can be split as 25 twos are, or it can also be split as 10 fives are. I think 10 fives are is the right combination. So factorizing this, I would get, so negative 10 and negative 5 is the right combination. So I can say x square minus 10x minus 5x plus 50 is equal to 0, which means that from the first two terms x is common. So you get x into x minus 10 minus 5 into x minus 10 is equal to 0. Therefore, x minus 10 into x minus 5 is equal to 0. So therefore, x is either 10 or x is 5. Both are positive parts, so both are valid numbers. Now, in case x is 10, then 15 minus x is going to be 5. And in case x is 5, then 15 minus x is going to be 10. So in both cases, you will observe that the two parts are 5 and 10. Right, so I can say the two parts are 5 and 10. Now if we want to do a quick check, let us find the sum of the reciprocal. Let's have a checkbox somewhere. Let's add a checkbox over here. So I want to find the sum of the reciprocal. So 1 by 5 plus 1 by 10. The LCM is going to be 10, and I have 2 plus 1, that is 3 by 10. So our answer is exactly right. The two parts are indeed 5 and 10. So again pausing for a few seconds before moving on to the next one. Moving on to the next question. Let's consider the following question. The sum of squares of two positive integers is 208. If the square of the larger number is 18 times the smaller number, find the two numbers. So again, let us take two numbers. So let the numbers be, I would say, let the numbers be x and y. Right now, we don't have any relation between these two numbers. So let's build the equations and then let's see if we can solve the two equations. So sum of these squares. So x square plus y square is equal to 208, that is given to me. This is my first condition. And now let's read the second condition. If the square of the larger number, so now between these two, let's assume some number to be larger. So let x be larger and y be smaller and y be smaller. Now it is given that the square of the larger number, so square of the larger number is going to be x square, is 18 times the smaller number, right? So 18 times the smaller number is going to be 18y, which means that x square is given as equal to 18y. So that is the second equation. So these are the two equations that we have to solve, right? And what I would do is I would simply substitute x square as 18y in the first equation. So I would say substitute x square as 18y in, say, the first equation. So what I get is 18y plus y square is equal to 208, which means y square plus 18y minus 208 is equal to 0. So now we have to solve this quadratic equation. Product is 208, which is 104 twos are. Nope, doesn't give us a sum of 18. 52 fours are. This also doesn't give us sum of 18. 26 eights are. Yes, I believe this is the right combination. We want the sum to be positive, so positive 26 and negative 8. And therefore we have y square plus 26y minus 8y minus 208 is equal to 0. Taking terms out as common, we get y into y plus 26 minus 8 into y plus 26 is equal to 0, which means y plus 26 into y minus 8 is equal to 0. And therefore either y plus 26 is 0 or y minus 8 is equal to 0, and therefore y equals negative 26 or y equals positive 8. And therefore the two numbers are one is 8, right? And now we need to find the other. So to find the other, let us substitute y as 8 in either of the two equations. I will substitute it in the second one. So let us first find the value of x. So let us pull this down. So substitute y as x, substitute y as 8 in the second equation. We get x square is equal to 18 times 8 which is 144, and therefore x is square root of 144, which is 12, of course with a plus or minus sign, but we again discard the negative sign because it's been told to us that they are positive integers, and therefore the two numbers are 8 and 12. So again pausing for a few seconds before moving on to the next one. Moving on to the next question. Let us consider the following question. A two-digit number is such that the product of its digits is 14. When 45 is added to the number, the digits are reversed. Find the number. Now, before we start framing our equations, let's use some common sense. Product of digits is 14. The only possibility is when the digits are 2 and 7, right? There's no other factor where both the numbers are single digit numbers. So 2 and 7 is the only option. Therefore, the number is going to be either 27 or 72. So what it means is, of course, mathematics is based on common sense. There is a lot of common sense that goes in mathematics. But even without solving any equation, we were able to arrive at the answer. Of course, it's going to be 27 because when you add 45 to it, 27 plus 45 becomes 72. So we already know that the answer is going to be 27. Okay. So now let us go and frame the quadratic equations to find the answer. A two-digit number. So I would say let the two-digit number be. Let the two-digit number be. I would have a tens place and a units place. Let the tens place be x. Therefore, the product of the two digits is 14. If one digit is x, the other digit will be 14 upon x, right? So if you multiply these two, you will notice that x into 14 by x, x cancels and the product remains 14, right? So let the two digit number be x and 14 upon x. Of course, you can also take the digits as x, y, right? X and y, and then say x into y is equal to 14. But over here, I decided to just eliminate the need of y because the first condition was given that the product is 14. So I took the digits as x and 14 upon x. Now let's take a look at the second condition. When 45 is added to this number, so let us write that condition. When you add 45 to this number, x and 14 upon x, these are the two digits. When you add 45 to this number, the digits get reversed. That is 14 upon x appears in the tens place and x appears in the units place. So now the actual value of this particular number, x is at tens place, so the value is going to be 10x plus 14 upon x is at the units place, so it is 14 upon x plus 45 is equal to 14 upon x is in the tens place, so its value is going to be 14 upon x multiplied by 10 because that's at the tens place and x is at the units place, right? So this is going to be my equation. Now I can quickly find the LCM on both sides. Before that, I can shift the x to the left hand side and combine it with 10x. So 10x minus x becomes 9x. and I can shift 140 by x to the left hand side. So it becomes minus 140 upon x. Minus 140 upon x is equal to 0. So therefore 9x and 14 by x minus 140 by x becomes minus 126 by x plus 45 is equal to 0. Now I can take the LCM throughout, right? The LCM is x throughout. So this becomes x, and 9x multiplied by x becomes 9x square minus 126 plus 45x is equal to 0. So x goes to multiplication with 0, and therefore this equation becomes 9x square minus 126 plus 45x is equal to 0. Dividing throughout by 9, I get x square plus 5x minus 14 is equal to 0. So now I should solve this quadratic equation. This is x plus 7 into x minus 2 is equal to 0, which means x is minus 7 or x is positive 2. Now the digit cannot be negative, right? X is a digit after all, it cannot be negative. So the digit is 2, right? So taking x equal to 2, I know that 14 upon x will be 14 upon 2, which is 7. So the digits here are x is 2 and 14 upon x is 7, which means that the number is 27. Therefore, the two-digit number is 27. A quick check: 27 plus 45 leads to 72, and the digits have been reversed. So our answer is right. So pausing for a few seconds before moving on to the next question. Moving on to the next question. A two-digit number is such that the product of its digits is 18. Okay. So again, using my common sense, what are my options? How will I get the product of digits as 18? The digits could either be 2 and 9. So the number could be 29 or 92. Or to get 18, it could also be 63 or 36. Right? Now it is said that when 63 is subtracted from the number, the digits interchange their places. So that is true only in case of this number. 92 minus 63 is 29, and hence the answer has to be 92. So we were able to find the answer even without solving the equation. Now let us frame the equation. So a two-digit number. So let the two-digit number be in the tens place. I would have x, and in the units place the product is 18. So in the units place it is going to be 18 upon x. Now when 63 is subtracted from the number, so when 63 is subtracted from the number, so I have x and 18 upon x. 63 is subtracted from this number, then the digits interchange their places. That is, the tens digit becomes 18 upon x and the units digit becomes x, right? The digits have interchanged their places. So this is the equation that I now have, and I'm now going to write the exact value of both these numbers. The exact value of this number is 10x plus 18 upon x. minus 63. Now 10x because x is in the tens place and 18 upon x into 1 because it is in the units place. This equals 18 upon x is in the tens place, so it becomes 180 upon x plus x. Shifting the x to the left hand side and 180 upon x to the left hand side, I get 10x minus x plus 18 upon x minus 180 upon x minus 63 is equal to 0. 10x minus x is 9x and the LCM here is x. For these two terms the LCM is x. 18 minus 180 is minus 162 upon x minus 63 is equal to 0. And therefore you can now find the LCM. The LCM is x, so you get 9x square minus 162 minus 63x divided by x is equal to 0. The x goes to the other side for multiplication. Therefore I get 9x square minus 63x minus 162 is equal to 0. Dividing throughout by 9, I get x square minus 7x minus 18 is equal to 0. So now you have a quadratic equation to solve, and I can of course factorize this as x minus 9 into x plus 2 is equal to 0, which means x is either 9 or negative 2. And if x is equal to 9, I can now find the digits. The digits are, the tens place was x and units place was 18 upon x. X is equal to 9, so I can replace x with 9. So this becomes 9. And 18 upon x becomes 18 upon 9. 18 upon 9 is 2, right? And therefore the number is 92. Therefore the two-digit number is 92. So pausing for a minute. Moving on to the next question. The difference of squares of two numbers is 45. So let the numbers be x and y. So I would say let the numbers be x and y. The difference in their squares, so x square minus y square is equal to 45. Now of course in these two numbers x has to be the bigger one, right? Because x square minus y square, which means x square is greater because the result is positive. So x is bigger and y is smaller. Now let's see what is the next condition that is given. So this is my first equation. Now the next condition is the square of the smaller number. So square of the smaller number is y square is actually 4 times the larger number. So it is given that y square is equal to 4 times x. This is my second condition, right? Now, of course, these are simultaneous equations. I can substitute y square as 4x. So substitute equation 2 in equation 1. We get x square minus, instead of y square, I have to substitute 4x is equal to 45, which means x square minus 4x minus 45 is equal to 0. And now I can factorize this. This is going to be x minus 9 into x plus 5 is equal to 0, which implies that, so this implies that x equals either 9 or x equals negative 5. Now we cannot take the negative number because we are assuming that both numbers are positive, and hence we assume that x equals 9. So substitute x as 9. We get y square equals 4x, that is 4 times 9, and y is equal to therefore 6. So therefore the two numbers are 9 and 6, right? Now, by the way, why didn't we take x as negative 5? It's not mentioned anywhere over here that the numbers are positive, so we should even consider x as negative 5, right? So now let's take x as negative 5. So substitute x equals negative 5. We get y square equals 4 times negative 5. So y square equals negative 20, which is now not possible, right? So negative number cannot be the square of any number, and this leads us to imaginary roots, or something known as complex numbers, which is not a real number, right? So y square equal to negative 20 does not yield a real value for y, and hence the valid answer is 9 and 6. The two numbers are 9 and 6. A quick check: 9 square minus 6 square is 81 minus 36, which is 45, and 6 square is 36, and 36 is 4 times 9. So these two numbers satisfy both the given condition, and hence our solution is right. I will again pause for a minute before moving on to my next question. Moving on to the next question. If the sum of the first n natural numbers is 420, find the value of n. So this is an arithmetic progression problem. If you remember, we had similar problems in arithmetic progression chapter. So it's given that the sum of the first n natural numbers. So what are natural numbers? Natural numbers are 1, 2, 3, and so on. And they are telling me that sum of the first n natural numbers. So we are taking n such numbers and their sum. So 1 plus 2 plus 3 and so on up till n terms. The sum is 420. Now we know that the sum of n terms of a AP, sum of n terms of an AP is given by n by 2 times 2a plus n minus 1 times d. This equals 420. So over here in this particular AP, a is 1, right? In this AP, a is the first term. So a is equal to 1. Then the common difference is the difference between two terms. So the difference is 2 minus 1, that is also equal to 1. So substitute these values here, I get n by 2. N is the number of terms, which is what we are supposed to find right now. So n by 2 times 2 into a plus n minus 1 times d. So d is going to be 1 again, is equal to 420. Okay, there is a small mistake in the question. It should have been 210 and not 420. Please excuse me for that error. So now we have the rest of the solution remains the same. There's no change. So therefore this is n times 2 into 1 is 2 plus n minus 1 is equal to, this 2 can go to the right hand side for multiplication. So it becomes 420. And now I can open up the brackets. Let us first simplify the bracket. So you get n times n plus 1 is equal to 420. And therefore n square plus n is equal to 420. Which means the quadratic equation is n square plus n minus 420 is equal to 0. So I'm going to pause for a few seconds. Let you take a look at the solution and then we will continue. And now I can find the numbers. So the product is 420, negative of course. Let's split 420 into two parts, say 42 tens are, but that doesn't yield a sum of positive 1. I can divide this by 2, so it becomes 21, and multiply this by 2, so it becomes 20. So therefore the numbers are positive 21 and negative 20. And therefore I get n square plus 21n minus 20n minus 420 is equal to 0. Now in these two numbers n is common. So n into n plus 21. In these two numbers 20 is common. So 20 times n plus 21 is equal to 0. Therefore I get n plus 21 times n minus 20 is equal to 0. Which implies n is either negative 21 or n is positive 20. And again now the first n natural number, so n cannot be negative. The number of numbers cannot be negative. So n has to be 20 in this case. So the sum of the first 20 natural numbers is going to be 210. So let's move on to the next question after pausing for a few seconds. Moving on to the next question. Let us consider the following question. If the sum of the first n even natural numbers is 420. So we have n even natural numbers. So natural numbers begin from 1, but 1 is not even. So the first even natural number is 2. So it's given that 2 plus 4 plus 6 plus continuing this for n terms. This sum is equal to 420. So now again this constitutes an AP. In this particular AP, the first term is A. So A is equal to 2 here. The common difference, the difference between any two consecutive terms is 2. And the number of terms is n. And it is given that the sum of the terms, that is Sn, is equal to 420. So Sn is given by n by 2 times 2a plus n minus 1 times d. Okay, so 420 is therefore equal to n by 2 times 2a, that is 2 times 2 plus n minus 1 times 2. Therefore 420 is n by 2 times. If I open up all the brackets, I get 4 plus 2n minus 2, and therefore I can say that 420 is equal to n upon 2 times 2 plus 2n. Now I can take a 2 out of the bracket as common, right? And therefore the equation turns out to be 420 is equal to 2n times 1 plus n divided by 2. So now 2 cancels, and therefore 420 is equal to n into n plus 1. Or I can say n square plus n is equal to 420, and therefore n square plus n minus 420 is equal to 0. This is my quadratic equation, right? Now I can think about solving this equation. Again, my product is negative 420 and the sum is positive 1. So let's start splitting 420. 42 tens are and still not giving me a sum of 1. Let's divide by 2. So 21 20s are, and bingo, this is my right option. So I get n square plus 21n minus 20n minus 420 is equal to 0, which means n into n plus 21 minus 20 into n plus 21 is equal to 0, and therefore n plus 21 times n minus 20 is equal to 0. This implies n is equal to negative 21 or positive 20. Now again, we discard the negative option because there cannot be negative number of terms, and therefore the value of n is equal to 20. The sum of the first 20 even natural numbers is going to be 420. So let me again pause for a few seconds before I move on to my next one. Moving on to the next question. If the sum of n successive odd numbers starting from 3 is 48. So what we are saying is 3 plus, so we are taking the sum of successive odd numbers. So 3 plus 5 plus 7 and so on for n numbers or n terms. Is this sum is equal to 48. We have to find the value of n. Again, this is an AP, so I can say that in this AP, A is equal to 3. A is the first term. The common difference is 2. That's the difference between two successive terms. And Sn is equal to 48. The sum of all terms is 48. So I know the formula for Sn. Sn is given by n by 2 times 2a plus n minus 1 times d. So Sn is 48 in this case. So 48 is equal to n by 2 times 2a is 2 times 3 plus n minus 1 times d. So n minus 1 times 2. I can shift this 2 for cross multiplication. So 96 is equal to n into 2 3s are 6 plus 2n minus 2, which means 96 is equal to n into 4 plus 2n. Opening up the brackets, the quadratic equation I get is as follows. So it is 96 equals 4n plus 2n square, and therefore 2n square plus 4n minus 96 is equal to 0. I can divide throughout by 2, so I get n square plus 2n minus 48 is equal to 0. This is the quadratic equation that I am supposed to solve now. Product is minus 48 and sum is plus 2. So I get n plus 8 multiplied by n minus 6 is equal to 0. And hence the value of n is either negative 8 or positive 6, right? Now again, there cannot be negative number of terms. Therefore, the value of n is equal to positive 6. Pausing for a few seconds before moving on to the next question. Moving on to the next question. Find two consecutive odd positive integers, sum of whose squares is 290. So we have two consecutive odd positive integers. So let the integers be x and x plus 2, right? We know that any two consecutive odd integers are also separated by a value of 2, and therefore the positive integers would be x and x plus 2. It's given that the sum of their squares, that is x square plus x plus 2 the whole square, is equal to 290, right? So these are two positive odd integers, x and x plus 2, and the sum of their squares, that is x square plus x plus 2 the whole square, is equal to 290. Let us solve this quadratic equation now. This can be opened up using a plus b the whole square. So x square plus 4x plus 4 is equal to 290, which means 2x square plus 4x plus 4 is equal to 290, which means 2x square plus 4x plus 4 minus 290 is equal to 0, or 2x square plus 4x minus 286 is equal to 0. Dividing throughout by 2, what we get is, x square plus 2x minus 143 is equal to 0. So now we need to split 143 into two parts. I believe it is 13 11s are, and it is positive 2, so positive 13 and negative 11. So x square positive 13x negative 11x negative 143 is equal to 0, which means x into x plus 13 minus 11 into x plus 13 is equal to 0, or x minus 11 times x plus 13 is equal to 0. And therefore the value of x is positive 11 or negative 13. Now we want positive integers, so negative 13 has to be discarded. Of course you have to mention this, right, in the solutions. And therefore the value of x is 11 The integers are 11, that's x, and x plus 2 is going to be 11 plus 2, that is 13. A quick check, these are two consecutive odd numbers and their square. So what is 11 square? 11 square is 121 and 13 square is 169. So if we take their sum, it is 290. So this satisfies the second condition as well, and hence our solution is right. We should express this in the statement form. The two consecutive numbers are 11 and 13. The two consecutive odd numbers are 11 and 13, right? So this is the end of today's session. Today we solved quite a few questions based on number systems. So we will now pause for a minute and end today's session here. Ending today's session over here.